Going to say what is initialization in Swift programming language. Initialization is the process of preparing an instance of a class, structure, or enumeration for use. This process involves setting an initial value for each stored property on that instance and performing any other setup or initialization that is required before the new instance is ready to use. You implement this initialization process by defining initializers, which are like special methods that can be called to create a new instance of a particular type. Unlike Objective-C initializers, Shift initializers do not return a value. Classes and structures must set all of their stored properties to an appropriate initial value by the time an instance of that class or structure is created. Stored properties cannot be left in an intermediate state. You can set an initial value for a stored property within an initializer or by assigning a default property value as part of the property's definition. First, we are checking what is an initializers and how we can assign values to properties. Let's check an structure. Is having an property temperature of type double, and I'm going to create an initializer. See, there is no params, just initialize the value of temperature to something. This is known as the initializer. That is how it works. So I'm going to comment this code. Compile time error. Missing argument for parameter temperature. So here we haven't assigned a value to the property temperature, but I am going to now there is no errors. So this is the second method of assigning a value to a property, that is default property values. That is, specify a default value as part of the properties declaration. Okay, these are the two methods for uh, setting initial values for stored properties. One is using an initializer, another one is providing a default property values. We can customize it. You can provide initialization parameters as part of an initializer's definition to define the type and name of values that customize the initialization process. Initialization parameters have the same capabilities and syntax as function and method parameters. We have a structure of Celsius. For parameter double, and I have an initializer with an parameter from heat type double. So I'm going to calculate the value of temperature in Celsius. Just simply put Fahrenheit. and another initializer with another parameter Kelvin of type W, temperature in Celsius is equal to Kelvin minus 2. So we have two initializers. See, one is Fahrenheit and another one is Kelvin. So this is how we can provide initialization parameters. The initialization is now dependent on the parameters. If your custom types has a stored property that is logically allowed to have no value, perhaps because its value cannot be set during initialization, or because it is allowed to have no value at some point later, declare the property with an optional type. Properties of option types are automatically initialized with a value of nil, indicating that the property is intended to have no value at during initialization. For example, class survey question. So in this response property is of type string and have not any value, so I am putting an optional value here. Initializer, we just need to provide the initializer for the text only. We don't have to provide the initial value for response, as it is a option value. Text string text. Got it. Let us check that q is equal to any question. So this is all about the optional types in command with the initialization. You can also assign a value to a constant property at any point during the initialization. For example, let us take this as a constant. This will work. Sorry, question dot text. Okay, good. So next is the default initializers. Swift provides a default initializer for any structure or class that provides default values for all of its properties and does not provide at least one initializer itself. The default initializer simply creates a new instance with all of its properties set to their default values. And we have a class name with optional type quality, quantity. quantity of type int. Is equal to shopping list item. So this is the default initializer. This is the case with the class. Let us check with the structure. Structure types automatically receives a member-based initializer if they don't define any of their own custom initializers. Unlike a default initializer, the structure receives a member-based initializer even if it has stored properties that don't have default values. The member-based initializer is a shorthand way to initialize the member properties of new structure instances. Initial values for the properties of the new instance can be passed to the member-based initializer by name. Stretch size bit equal to 0. Okay, so I didn't, there is no initializer defined for the structure. Let us check what are the default or the member-based initializer we got in the structure. Size. See, we got three options. One is the option to provide width and height. Another one width 1.0 and next one see so these are the member-based initializers for this structure. You can omit values for any properties that have default values. In this example, both the properties have values, so you can omit either one or both the properties. Can call other initializers to perform part of an instance's initialization. This process, known as initializer delegation, avoids duplicating code across multiple initializers. For value types, you can use self.init to refer to other initializers from the same value type when writing your own custom initializers. You can call self.init only from within an initializer. If you define a custom initializer for a value type, you will no longer have access to the default initializer. Let's take an example. I have a structure size with properties and another structure size with properties x y equal to 0. And I have this what happened. Sorry. Point. Structure rectangle. We have the origin and size. Origin of type point. I am initializing that with point, and another property size, initializer of type size. Okay, so here I am going to provide the initializers. First one is the on default initializer init, the no parents, as we have both the params have the default values. The first, this initializer is functionally the same as the default initializer that the structure would have received if it did not have its own custom initializers. And another initializer is init with the origin and point, origin and size. Self dot this initializer is functionally the same as the member-wise initializer that the structure would have received if it did not have its own custom initializers. And we have another initializer in it. Something is complicated. Let us create the center of type point and size property. And we are going to calculate the center point, that origin x equal to x minus the same was let origin y equal to center dot y minus dot height divided 2. So we calculated the origin x and origin y. Next I have to calculate the center point and size. For that I am going to call this initializer. So I'm going to call self dot init origin. That's a point, right? So we have the x and y. I'm going to create a point x of value origin x and y value origin y. Second is the size. Okay. Okay, fine. So this is slightly more complex. It starts by calculating an appropriate origin point based on the center point and a size value. It then calls or delegates to the init initializer, which stores the new origin and values in the appropriate properties. So this is how initializer delegation works for the value type. Next we can check how the delegation works in the class type. Before that we need to check the class inheritance and initialization. All of a class's stored properties, including any properties that the class inherits from its superclass, must be assigned an initial value during initialization. SIP defines two kinds of initializers for class types to help ensure all stored properties receive an initial value. These are known as designated initializers and convenience initializers. First, check the designated initializers. Designated initializers are the primary initializers for a class. A designated initializer fully initializes all properties introduced by that class. and call an appropriate superclass initializer to continue the initialization process up to the superclass chain. Every class must have at least one designated initializer. In some cases, this requirement is satisfied by inheriting one or more designated initializers from a superclass. Next, the convenience initializers. These are the secondary or the supporting initializers for a class. You can define a convenience initializer to call a designated initializer from the same class as the convenience initializer with some of the designated initializers parameters set to default values. You can also define a convenience initializer to create an instance of that class for a specific use case or input value type. You don't have to provide convenience initializers if your class does not require them. Create convenient initializers whenever a shortcut to a common initialization pattern will save time or make initialization of the class cleaner in intent. The syntax for designated initializers look like this. These are the common initializers we seen before. Here may have parameters. And for the convenience initializers, there is a keyword convenience before the init initializer. That is the one difference between designated and convenience initializer syntax. To simplify the relationship between designated and convenience initializers, Swift applies the three rules between initializers. That is, one is a designated initializer must call a designated initializer from its immediate superclass. And the second one is a convenience initializer must call another initializer from the same class. Third one is a convenience initializer must ultimately call a designated initializer. So the designated initializers must always delegates up, whereas the convenience initializer must always delegate across. Inheritance and overriding. Unlike subclasses in Objective-C, Swift subclasses do not inherit their superclass initializers by default. Swift's This approach prevents a situation in which a simple initializer from a superclass is inherited by a more specialized subclass and is used to create a new instance of the subclass that is not fully or correctly initialized. If you want a custom subclass to present one or more the same initializer as its superclass, you can provide a custom implementation of those initializers within the subclass. When you write a subclass initializer that matches a superclass designated initializer, you are effectively providing an override of that designated initializer. Therefore, you must write the override modifier before the subclass's initializer definition. This is true even if you are overriding an automatically provided default initializer. But if you write a subclass initializer that matches a superclass convenience initializer, that superclass convenience initializer can never be called directly by your subclass as per the rule. So there is no need for the override modifier for the convenience initializer. Let us check an example. We have a class vehicle with properties and a computed property description So this is our class, and let me create an instance of a class. And another subclass named bicycle with a superclass vehicle. Here I am going to override the initializer, default initializer of vehicle. So override init. I'm going to change the number of wheels equal to 2. There will be an error because the self used in property access number of wheels before super.init. So we should use super.init before any modification in the subclass. Okay, we create an instance of this class. Okay, so good. Here we should provide this initializer, otherwise there will be error. Next, another class which inherits the vehicle, and there is an property called color of type string. I am initializing this with an initializer only for this class. Sorry, initializer color. Okay, good. And so here please check it, there is no node for calling the super.init here. This will also work. So if a subclass initializer performs no customization in phase 2 of the initialization process and the subclass has a 0 argument designed initializer, you can omit a call to super.init after assigning values to all of the subclasses stored properties. We complete this class. I am also overriding the description. Description. So it is with color white. So this is all about initializer inheritance and overriding. Next is the automatic initializer inheritance. Subclasses do not inherit their superclass initializer by default. However, superclass initializers are automatically inherited if certain conditions are met. Assuming that you provide default values for any new properties you introduce in a subclass, the following two rules apply. Rule 1: if your subclass doesn't define any designated initializers, it automatically inherits all of its superclasses designated initializers. Rule 2: if your subclass provides an implementation of all of its superclasses designated initializers, either by inheriting them as per rule 1 or by providing a custom implementation as part of the definition, then it automatically inherits all the superclasses convenience initializers. Next is the failable initializers. It is sometimes useful to define a class structure or enumeration for which initialization can fail. This failure might be triggered by invalid initialization parameter values, the absence of a required external resource, or some other conditions that prevents initialization from succeeding. To cope with initialization conditions that can fail, define one or more failable initializers as part of a class structure or enumeration. You write a failable initializer by placing a question mark after the any keyword. A failable initializer creates an optional value of the type it initializes. You write the return nil within the failable initializer to indicate a point at which initialization can fail. Let us take an example. The sys in class provides an failable initializer. Let us check it. We have double variable and another variable. Okay, so the normal in class provides some exactly is there. It actually returns an integer value. So it returns an optional. We can use the optional binding. Okay, value 1. Exactly of pi. Actually it going to convert a pi double value to integer. It will be null. So let us check what is have. You got the error. if I put the whole number, it will work. Okay, this is the failable initializers provided by the int. Let us create our own version. We have a structure animal, then constant property species of type string, string start. So I'm going to put an initializer with string. So I am going to declare this as a failable initializer, so that I need to put a question mark here, then I can return nil here. So I'm checking if species is empty, then empty, then just return null. Return nil, and I am setting the value. Okay, good. Let us check the result. So this will be this will return an instance of type optional type. So I am using the optional binding. Sorry. Okay, it's a success. I'm going to change the value to nil. So it is failure. Okay, this is a failable initializer. You can use a failable initializer to select an appropriate enumeration case based on one or more parameters. The initializer can then fail if the provided parameter do not match the appropriate enumeration case. Just declare an unit, the cases Kelvin, small letter, and Fahrenheit. Okay, I'm going to declare an initializer. I'm input, the input will be character. Okay, I'm doing a switch case symbol. If it is capital letter K, the case will be self dot Kelvin. Likewise, the conditions, if it is C, it is Celsius, it is F, then Fahrenheit. So I'm just going to return nil if the symbol is different from K, C or F. So return nil for that. You see, only failable integers can return value, so I need to put a question mark here. So this is okay. Let us check it. Let T is equal temperature unit of symbol K. If unit, I'm just printing success or not. So this will be success. I'm now going to see this. This is how we can use the failable initializer within an enum. So what will happen if we provide the raw values to the enumeration cases? Let us check it. It's equal to K C Fahrenheit. So we provided initial values. It's not the row type. The row type will be character. So we don't need this. And this will be temp unit or raw value. Success. So the enumerations with raw values automatically receive a failable initializer. Next, let us check how the propagation of initialization failure works. A failable initializer of a class structure enumeration can delegate across to another failable initializer from the same class structure or enumeration. Similarly, a subclass failure initializer can delegate up to a superclass failure initializer. In either case, if you delegate to another initializer that causes initialization to fail, the entire initialization process fails immediately and no further initialization code is executed. Let's check with an example. We have a failable initializer name is empty and just returning nil, otherwise okay. So I'm going to create another class which extends the product and having a parameter quantity of type int, quantity of type int, and having an initializer with a name, string and quantity integer. This will be also a failable initializer. So I'm going to check the quantity is greater than 1. If quantity is less than 1, I am going to return it. Otherwise, I'm going to self dot is equal to quantity and calling the superclasses initializer. So this is how the propagation of initialization failure works. Got it. Let's check the result. So I'm going to declare a value, so 0. The result will be failure. It comes here. Also going to check the value of name. This also works. Okay, good. Then next we have to check the overriding a failable initializer. You can override a superclass failable initializer in a subclass, just like any other initializer. Alternatively, you can override a superclass failable initializer with a subclass non-failable initializer. Alternatively, you can override a superclass failable initializer with a subclass non-failable initializer. This enables you to define a subclass for which initialization cannot fail, even though initialization of the superclass is allowed to fail. Note that if you override a failable superclass initializer with a non-failable subclass initializer, the only way to delegate up to the superclass initializer is to force unwrap the result of the failable superclass initializer. You cannot override a no-failable initializer with a failable initializer. Let us check with the example. I have a document class with name, string, and an initializer. This is an empty initializer. That means a default initializer. We have to provide this name, but right now there is none, so we are going to define this as a optional. Okay. Next, I am going to create another initializer with name, string. If name is empty, then going to return nil. So it is a failable initializer. Okay, so I'm going to create another class. Okay, subclass. Oh no, name it automatically. Name a document. That extends the document class. So we need to automatically name the document I'm going to override the default initializer. Calling super.init and self.name equal to untitled. Okay, and override another initializer. Check the name. Otherwise I'm just saving the name. So this is how override the failable initializer. Next is the required initializers. Write the required modifier before the definition of class initializer to indicate that every subclass of the class must implement that initializer. You must also write the required modifier before every subclass implementation of the required initializer to indicate that the initializer requirement applies to further subclasses in the chain. You do not write the override modifier when overriding required designated initializer. See the situation. I have a class some class and having an unit, but is nothing is there. So I'm going to make it required. So we should provide a required keyword is also here also. Required modifier must be present all overriders of the initializer. So this is about the required initializers. How we can set a default property with closure or functions. If a stored property's default value requires some customizations or setup, you can use a closure or global function to provide a customized default value for that property. Whenever a new instance of the type that the property belongs to is initialized, the closure or function is called and it returns the value that is assigned as the property's default value. Let us check the example. We have a structure named chessboard. Having a property board colors actually is an array of boolean.
So I am going to provide value for this board colors with the help of an closure. For that, equal to, this is the closure expression, and I need to give the parenthesis here and the code enter here. Cannot convert specific type boolean. Okay, so I have an bold colors property, and I'm going to assign value to the property using a closure. Inside that closure, I have an temporary border array of boolean, and I'm going to return that value. So the logic goes here. So basically, in that array, we are storing boolean values of true and false based on the color white or black. So we have a boolean black is equal to false, and I am going to loop it 2 times for 1 to 8, then another loop, one to 8. Here I am going to add elements in temporary array. And is black to here. Now I will change here is black is equal to here also going to change the boolean value. Okay, so this is a closure function, and we have another function to check whether the elements in that temporary board array is true or false. Square is black. At the position of row and column, for row and which returns a boolean. So here return board colors of row into each plus okay. So this is it. Let us check how it goes. Is equal to dot. So first I'm going to check if the 0 and 1. that's true, and for 2 that is false. So here what we have to check is the importance of this parenthesis. The closures n curly braces is followed by an empty pair of parentheses. This tells shift to execute the closure immediately. If you omit this parenthesis, you are trying to assign the closure itself to the property and not the return value of the closure. So here whenever a new instance of chessboard is created, the closure is executed and the default value of board colors is calculated and returned. So this is all about how we can use closures or global functions to assign default properties